Hi, my name is Kara Glidden, and I'm from Professor Lezebnik's Human Inheritance class at Bentley University. Today I'm going to be talking about osteogenesis imperfecta. Osteogenesis imperfecta is a genetic disease that affects the strength of a person's bones. Patients with osteogenesis imperfecta have bones that break easily without any real cause or force. They will have hundreds of fractures in their lifetime. OI is also known as brittle bones disease because of the symptoms. The severity can vary because there are different forms of OI. Right now there are four main types. Between 25,000 and 50,000 people are affected in the US. Osteogenesis imperfecta patients will have brittle bones that have frequent bone fractures and bone pain. They will also have a blue-gray tint in the white of the eye, dentiogenesis imperfecta, which affects the teeth in 50% of OI patients, scoliosis or a curved back, hearing loss, muscle weakness, short stature, low bone density, and respiratory problems, as long as cardiac issues, easy bruising, and fragile internal organs. There are four main types of OI. Type 1 is the mildest form, and it is also the most common. A patient will experience few fractures in childhood and adolescence, but there will be less frequent fractures in adulthood. These breaks will be caused by slight force. Type 2 is the most severe type. Babies will have fractures before birth. They have a narrow chest due to ribcage breaks, and they have underdeveloped lungs and short bowed limbs. They will likely die before birth or shortly after due to respiratory issues from the encaved chest. Type 3 is relatively severe. They have life-threatening injuries due to breaks in the womb, and the severity of the bone weakness will progress. These patients will be unlikely to walk. In type 4, there's a mid-range of symptoms. 25% of the babies will be born with fractures. In childhood, they will have bones that are bowed, but then when they grow up, they will be more normalized. Osteogenesis imperfecta is a single dominant mutation in the collagen gene, usually caused by a de novo mutation. The mutation will affect collagen gene 1 or collagen gene 2. Collagen is a protein that affects bones, skins, and connective tissue. The collagen gene 1 can be found on the long arm of chromosome 17, and collagen 2 is located on the long arm of chromosome 7. In type 7, it is a recessive mutation in the CRTAP gene, which is different than the gene affected in all of the other types. These might either be inherited by a parent who has either one or two of the alleles, and also by a de novo mutation. Osteogenesis imperfecta has been a prevalent genetic disease for thousands of years. According to Belgian Bone Club, OI has been observed in an Egyptian infant mummy dating back to 1000 BC. It is currently still in a museum. In addition, Ivan the Boneless from the 9th century Denmark is now thought to have OI. Stories say that his legs were so soft that he had to be carried to the battlefield. In the 1600s, studies of fragile bones and hearing loss appeared in medical publications, but it wasn't until the 1900s and eventually the 1970s that the disease was officially recognized and characterized based on the severity. Osteogenesis imperfecta is diagnosed through X-rays and doctor examinations. Additionally, lab biochemical testing or DNA sequencing of the collagen genes may be used. Right now, there is no treatment besides supportive therapy for OI patients. Supportive therapy is when the child's doctor, a genetic expert, an orthopedic doctor, and rehabilitation medicine work together to help the patient handle their symptoms. But there is currently research going on to look at more into the gene therapy and what's going on with that, and drugs that will help a person with OI grow or help them build stronger bones. The reason that I chose this topic was because I read Handle with Care by Jodi Picoult, which is a really interesting book about a young girl with OI and the effects on her family. It also has to deal with medical ethics because the mother has to decide whether or not she would have kept the baby if she had known during her pregnancy that her baby would be severely disabled. Thank you.